In this module, we will cover IPSec VPN. IPSec VPNs are heavily used in today's IT infrastructure to extend corporate networks across the Internet. Whether you are setting up an IPSec VPN using a FortiGate unit or another vendor device, the principles and associated business requirements are usually the same. These are the topics we will cover in this module. We will present an overview of the IPSec technology, which includes Internet Key Exchange, Phase 1, Phase 2, Diffie-Hellman, and Quick Mode selectors. You will also learn about policy-based and route-based VPNs and how to use the VPN monitor. This module is an introduction to IPSec VPNs. It is the first of two modules dedicated to this technology in the FCNSA and FCNSB curriculum. The other IPSec module, which is part of our FCNSB training, offers a more advanced analysis. By the end of this module, you should be able to identify the various components of an IPSec VPN, the IKE phases and mode, and the differences between policy-based and route-based VPNs. You will also learn to configure a point-to-point VPN between the two FortiGate devices and use the IPSec VPN monitor to check the status of each tunnel. A virtual private network allows users to remotely and securely access private resources as if they were locally connected. It is generally used to send private information over a public network, so it is not only implemented for providing access to mobile users, but also for interconnecting geographically dispersed networks across the Internet. The user data traveling inside a VPN is encrypted, so it cannot be intercepted by unauthorized users. It also uses different techniques to ensure that only authorized users can establish the VPN and access the private resources. One of the common ways of implementing a VPN is by using IPSec. IPSec is a set of standard protocols used for authentication and encryption. It meets the following requirements: authentication to verify the identity of the sender, data integrity to prove that the data has not been tampered with as it travels across the network, and data confidentiality to ensure that the data is unreachable to everyone except the intended recipient. IPSec VPN creates what is called a tunnel at layer 3 of the OSI model. This means that the IP packets that need to be transported to the remote side are encapsulated over IPSec. The encapsulated IP packet remains unaltered. The header of the IPSec packets contain information that identifies the endpoints of the VPN tunnel. An IP application does not have to be designed to use IPSec. The tunneling and encryption happens transparently to the upper layers of the OSI model. IPSec increases the complexity and overhead of the data interchanged. For example, it cannot depend on TCP to manage reliability and fragmentation. Also, bandwidth requirements for IPSec are higher than the ones for sending the information unencrypted. The IPSec standard specifies a series of keys that are used for encryption and authentication. A protocol called Diffie-Hellman is used first to generate a common private key by sharing only the public keys of both ends. A third party that would have access to the message exchanged containing the public keys cannot determine the secret key. The common private key is then used to calculate additional keys, which are the ones used for symmetric encryption and authentication. The standard also specifies a mechanism called perfect forward secrecy that uses Diffie-Hellman to recalculate a new common secret key each time the Phase 2 session key expires. We will see in the next slide what Phase 1 and Phase 2 are. In order to create an IPSec tunnel, both devices must establish their security associations and secret keys, which are facilitated by the IKE protocol. The IPSec architecture uses a security association as the basis for building security functions into IPSec. A security association is simply the bundle of algorithms and parameters being used to encrypt and authenticate data traveling through the tunnel. In normal two-way traffic, this exchange is secured by a pair of SAs, one for each traffic direction. Essentially, both sides of the tunnel must agree on the security rules. If both sides cannot agree on the rules for sending data and verifying each other's identity, then the tunnel will not be established. IKE uses two distinct phases, Phase 1 and Phase 2. Phase 1 authenticates the parties involved and sets up a secure channel to enable the key exchange. Phase 2 negotiates the IPSec parameters to define the tunnel. In the next slide, the phases will be explained with a little more detail. IKE Phase 1 negotiates a pair of matching IKE SAs for handling authentication and establishing a secure channel that will be used to negotiate the Phase 2. It also performs a Diffie-Hellman exchange to generate the keys that are going to be used by Phase 2. Two Phase 1 modes are available: Main mode, which requires the interchange of 6 packets, and Aggressive mode, which requires 3 packets to be interchanged. The differences between the two modes are explained with detail in our advanced IPSec module. The Phase 2 negotiates the IPSec SA parameters using the already secure Phase 1, known as IKE SAs. It renegotiates those parameters regularly to increase security. Also, as mentioned in a previous slide, perfect forward secrecy can be enabled to have Diffie-Hellman recalculate a new common secret key each time the Phase 2 session key expires. We can have more than one Phase 2 in each Phase 1. As an example, for cases where we want to use different encryption keys for each subnet whose traffic is crossing the tunnel, the Phase 2 only has one mode, which is called Quick Mode. During the Phase 2 creation, we must configure a pair of settings called Quick Mode selectors. They are used to identify and direct traffic to the appropriate Phase 2 in case where there is more than one Phase 2 per Phase 1. In other words, it allows security associations with different granularities. The selectors behave similar to a firewall policy. The VPN traffic must match the selectors in one of the phases. The VPN traffic must match the selectors in one of the Phase 2s. If it does not match any selectors, the traffic is dropped. When configuring the selectors, we must specify the source and destination IP subnet to be allowed in each Phase 2. Additionally, we can specify the protocol number and source and destination ports for the allowed traffic. The Quick Mode selector configuration for dial-up VPN is covered in our advanced IPSec module. But in the case of point-to-point VPNs, configuration on both sides must mirror each other. In other words, the source subnet on one side must be the destination subnet on the other. There are two ways of creating an IPSec VPN configuration on a FortiGate device: route-based and policy-based. On one hand, when you create a route-based Phase 1, a virtual IPSec interface with the Phase 1 name is automatically added to the FortiGate device. Usually, 2 firewall policies with the action of accept are required in this case. One policy using the IPSec interface as source to allow the sessions originated from the remote site, and one firewall policy using the IPSec interface as destination to allow sessions originated from the local site. Additionally, a route-based VPN configuration requires the FortiGate device to route the traffic to the IPSec interface. This is usually achieved, as we will see later, by adding a static route. On the other hand, a policy-based configuration usually requires only one firewall policy with the action of IPSec. This policy is applied as bidirectional, allowing sessions that originate from either side of the tunnel. By default, policy-based VPNs cannot be created from the GUI. The CLI setting, GUI Policy Based IPSec, can be used to enable the access from the GUI. It is important to mention that the configuration modes have local significance only. You do not need to configure both sides of your VPN in the same way. You can have one side of the tunnel configured as route-based and the other side as policy-based. Indeed, you can change a VPN configuration on one side from one mode to the other mode as long as the Phase 1 and Phase 2 settings remain the same. You do not need to do any changes on the other side. The IPsec traffic does not change. In our old documentation, route-based used to be called interface-based, and policy-based used to be called tunnel-based. So, how do we know when to use policy-based and when to use route-based? As a general rule of thumb, you should always try to use route-based, as it offers more flexibility and control. As route-based uses an IPsec interface, we can implement very complex routing scenarios, for example, as the cases where tunnel traffic is required to be routed with policy-based routing. However, policy-based VPNs must be used when the FortiGate is in transparent mode or L2TP over IPsec is required. In the cases of routing protocols and GRE over IPsec, route-based VPNs is the only option. Configuring an IPsec VPN on a FortiGate device involves at least 3 steps. One additional step is usually required when doing route-based VPNs. The first step is to create the Phase 1. The second step is to create one or more Phase 2s. The third step is to create the firewall policies. Finally, and only in the case of route-based VPNs, additional routing configuration is required. Let's see each step with more detail in the next slide. This is a sample of the screen where you create a Phase 1. You must configure the IP address of the other FortiGate, the interface where the tunnel terminates, Phase 1 mode, aggressive or main, encryption and authentication algorithms, and so on. Most of the IPsec VPNs are implemented using a pre-shared key as the authentication method. In those cases, the same pre-shared key must be manually entered on both sides. As a matter of fact, what is important to know at this point is that most of the FortiGate Phase 1 configurations must match on both sides. It is during the Phase 1 creation that we specify the type of VPN configuration, either route-based or policy-based. This is a sample of the screen where you create a Phase 2. You must specify a name for the Phase 2 and bind it to a Phase 1. You can then click on the Advanced button to open and edit additional Phase 2 settings such as the encryption and authentication algorithms, perfect forward secrecy, and the quick mode selectors. The source address in the quick mode selector is usually the subnet that is local to the FortiGate unit. The destination address is usually the subnet at the other end. If there are multiple local or remote subnets, we can create more than one Phase 2 or use address groups containing multiple subnets as source or destination. Alternatively, in some cases, the quick mode selectors are kept as 0.0.0.0/0, meaning that no traffic filtering is done at this level. All the filtering is done with firewall policies. In the case of policy-based VPNs, we must create one firewall policy of the type VPN and subtype IPsec. Then, we must select the Phase 1 we have previously created in Step 1. Alternatively, we can create a new VPN from the firewall policy itself, merging Steps 1, 2, and 3 into a single step. In the case of route-based VPNs, the firewall policy is different. It must be of type firewall and subtype address. As mentioned, the name of the IPsec interface matches the name of the Phase 1. so we must use that interface name as either the source or destination interface for the policy, depending on which direction we want to apply it. In the case of route-based VPNs, additional routing configuration is needed to route the tunnel traffic to the IPSec interface. This is usually achieved by adding a static route for the remote subnet pointing to the IPSec interface. In the GUI, there is a tool to monitor the status of your IPSec VPNs. Through this monitor tool, you can see how much traffic has crossed each tunnel. You can also start and stop individual tunnels and get additional details. If the tunnel is up, there will be a green arrow appearing next to its name. If it is down or not in use, then a red arrow is displayed. The IPSec monitor is located in the VPN menu section of the GUI. Every phase 1 will show up here, along with additional information about them. This example shows 3 different VPN tunnels: Client VPN, Home VPN, and Office VPN. The Phase 1 Office VPN shows up twice because it has 2 separate Phase 2s. The other VPNs have 1 Phase 2 each. For each Phase 2, we can see the Phase 1 name, key life, remaining time, status, and the quick mode selectors. Now it's time for the IPSec lab. In this exercise, you will monitor an IPSec VPN connection between 2 FortiGate units. You will also examine the differences between policy-based and route-based VPNs.